My name is Maor Tal, and welcome to my session. I'm in Your PaaS. Give me 1 sec. Sorry, it's really just stuck. Okay, you want to see me? Okay, so today we will discuss how the platform as a service can be abused by external attackers to gain access to your Azure cloud. Based on a recent use case that I had, but I won't dive into the Azure fundamentals and basic setup, but no worry, I will leave a place for questions in the end. So who I am, like I said, my name is Maor Tal. I'm a security researcher and the founder of Sikreta Labs. I am a penetration tester and red teamer with over 7 years on web, mobile, cloud, and red team. I'm also an author of the Web Application Advanced Hacking book, which discuss about bug bounty and web application advanced technique. And when I have some spare time, honestly, I usually don't, I am doing some bug bounties for the fun. So let's start. Today's agenda, we will discuss about PaaS, what is PaaS, what is Azure App Service. I will share with you my external playbook. How do I approach to such an external engagement? And we understand how it's done from the attacker's perspective, and I will share with you a lot of examples through the way. So let's start with the basic. What is platform as a service? Platform as a service is a service model that provides us an agile solution for a rapid deployment and development of applications without managing the underlying infrastructure. Think about it. No need to deploy virtual machines, set up configuration, networking. It just helps us to deploy our code to the platform. So when we are talking about an app service, is the Azure offering, which is a service, a fully managed service under the platform as a service, offering an agile and rapid deployment for developers and businesses. What's great about it is that Azure is taking care about everything from the infrastructure perspective. So it does almost everything for us in terms of deployment, updating, patching the OS, all the hard work of the infrastructure. And all we need to do usually is to look up on the ready-to-go template from the Azure marketplace, as you can see on my slide. And even deploy our custom code inside a runtime, and we are ready to go. Seriously, no deployment issues, no working with the infrastructure, just deploy our code and we are ready to go. So moving ahead to our victim cloud, this is the architecture that we try to penetrate into. As we can see here, the cloud victim has 2 different subscriptions with several resources. And also, the customer use a custom domain to run his application under his tenant. We don't know what is behind the domain, so that will be our first step in our investigation. But before we move ahead to the actual penetration test process, we need to understand the 5 important step when it comes to the app service penetration testing. The first one, similar to the external attack surface kill chain, we will explore our external attack surface, then look for any entry point, and then after the initial foothold, we do some internal enumeration within the cloud service, and finally conduct a lateral movement inside our app service. So let's start with our external Recon, the reconnaissance part. So a few baseline we know, unlike in external engagement, in regular external engagement, we have much more information to work with when it comes to external attack surface from a cloud perspective. Because every service deployed in the cloud has a predictable URI Once we know the service predictable URI, we can see which service is running and maximizing our efforts. For example, for Azure service is Azure website.net, etc., etc. Okay, so let's see the first demo. In this demo, I will start to looking for the CNAME record of the cast domain. Yes, see in a moment. Great, so now we can see that in the app escalatesecurity.com, it actually points to the Sikreta blog.azure.net. So that's great, but we need to know more information. So with that in mind, we know we start with the Sikreta and then some appendix like blog, HR. So we will use another tool to automate the process and see if there is any other asset for this Sikreta based thing. And now we can see there is a few more assets except from the blog. So that's great. That will be our attack surface. And the next part is finding the initial entry point. This is the second step for our engagement. But do keep in mind, we have the attack surface and we need to find the best way to get an entry point. Please remember, there is no difference between a regular app we deployed on on-prem, on our service, and versus a cloud-based application, in this case, the server app. The only difference is the infrastructure is managed by Azure. So as a result, all the classic top 10 vulnerabilities are still applying. And if we are following a basic checklist, we will start with the exposed admin interfaces. And when we start, we will find that a Sikreta blog is running a WordPress, which has an exposed admin interface. As we are an external engagement, we will run a tool to brute force the credentials for the admin interface. Let's see how it goes. We will run our tool against the domain. You will find our admin interface, enumerate the accounts existing in the application, and brute force our account. Great, and we found there is an admin in our panel. So we are now have access to the administration panel running under the app service. From this step, we are getting an initial foothold in the system. Ideally, we should aim for a command execution on the app service VM. And once we have a command execution, we can continue to a more advanced step. So we will try to avoid some noisy techniques. So the Azure firewall or any rules in between won't detect us. Let's see. So we are having an access to the WordPress, prepare our exploit with our command, copy it to the main template of our blog, keep it. So next time, we don't need even to log into the system. We just need to access to the main website. So it still work and function normally, while we can execute our command, for example, listing all the files. Great, now we are having a command execution on the app service. The next part is to see if we can extract some information which help us to do some internal cloud enumeration. So far, we found our way into the application and getting the capabilities of running server commands. That's great. So now the low-hanging fruit stage is starting. We need to find pieces of the puzzle and see what would allow us to connect and access other protected resources. So we will start with something cool that I usually start with is the Azure application settings feature. So what is Azure application settings? This feature is a part of the provisioning VM process. So when you are set up your application, you set up a name, a password, a database host, an administrator password. Everything is saved, encrypted on transit, but is available as a plain text inside the virtual machine. Therefore, if we will be able to execute commands on the operation system, we can read these values using the environment variable. So as we can see, using the export command, we will be able to retrieve all the app service environment variables within the application settings. In this case, we can see the connection information for the database. And if we use this, we could access the database, but it's out of scope. Please keep in mind that I just showed the presentation, but we can access the MySQL database. Now, what next? So far, we have a command execution on app service and access to the application MySQL database. Let's go for the crown jewel, or in our case, the managed identity. So what is managed identity? Managed identity is a great feature that allows us to access other restricted resources within the Azure tenant. So if we have an access to the managed identity VL, that means we can be inside the Azure tenant and request for other resources. So based on Azure REST API, as we can see in the screenshot, to get a managed identity access token, we need to send 2 values of identity address in order to get this JWT token. So let's see a demo. Now we can see we execute an export, found the identity values inside the environment variable. So in order to exchange these values for a valid token, we create our payload. Wait, I think it didn't copy it. Okay, now we didn't. We just copy our payload. Yes, and once we prepare our payload, we kind of perform a necessary attack on the servers. And now we are getting the access token of the managed identity. That's great. So we have the managed identity. What it will be the next step? The next step will be to take this managed identity access token and connect into it. How? Using a Azure PowerShell model provided by Azure. Is free and you can download it from Microsoft. And using Azure, the Azure ARM, the Azure Resource Manager, we can exchange the access token to get an access to the other resources, like we said. Let's see an example. Now we are having the access token, prepare the access token. Great, and now we try to connect it. We'll provide our access token. Access token. And we will provide the account ID, which is the client ID returned us in the JWT response. Wait a few minutes and see. We are already logged in. Great, so we have a connection to the research tenant. Let's see if we can research a subscription. So let's see if this subscription has more permission, but probably we saw there is only a vault permission. But as we saw in the first second of the video, there is 2 subscriptions. Let's see what the second could give us. So we know that the first one has only a vault accessible. So inside the research, we can only access to the Azure vault. But now let's see the assignment. Yeah, we can see there is a key vault security officer assignment. Allow us to list the secret and see security information stored inside the vault. Now let's see the subscriptions we have. Okay, we have 2 subscriptions. One is research, and the second is DevOps. Let's try to switch to the second subscription. Okay. Great, and now we switch from research to the DevOps, and we are logged inside the DevOps. See the resources. And now we are able to access the Sikreta files, which belong to other resource group. So now the last part of the puzzle we need to do is detect an IAM policy which allow us to escalate more. So let's continue with that. Inside the new subscription, we list all the rule assignments to see what more we can do with that account. As we can see, we have a reader access for one of the subscriptions, and we also have a contributor and owner. I know this is not ideally, but sometimes a managed identity could be linked to other highly privileged account. So in that case, we started from 0 to hero. Remember our starting point, we started as an external attacker. So based on the information we have seen, we can use the excessive permission of the second subscription to access other cloud resources as either owner or contributor. So we reach to the end and we finally get our control on the cloud of the victim. Few takeaways from these sessions. While Azure Platform as a Service provides an amazing platform for deployment, the attacker surface doesn't change. In fact, when it comes to the reconnaissance part, it will allow multiple ways to get into your cloud. And it becomes a blind spot for most of the cases. So what would be the recommendation? Consider an attack surface management to monitoring any public exposed platform as a service asset to reduce the additional attack surface. And also keep following, please, about all the application best practice. Don't forget OWASP Top 10, NIST, whatever framework or methodology you prefer. Just reduce the attack surface and review the IAM and access policies. Ensure that unnecessary policies are deleted. And again, review the firewall rules. Remember, by default, the policy might not suit to your tailoring conditions. So keep in mind.